Okay, now we're getting back into our chapter on trigonometry with section 4.2, trigonometric functions on the unit circle. Now this is where the rubber meets the road. This is where you really have to bear down on this information, because this is where we're going to get our introduction to the 6 trigonometric functions and how they are defined. We start off with the idea of defining them using a unit circle. The unit circle, remember, is the circle whose center is 0, 0, and whose radius is 1. I tried to draw an example of that right here. It's not a very good circle, sorry about that. We draw an angle in standard position in such a way that its initial ray is on the positive direction of the horizontal axis, the x-axis, and counterclockwise positive, clockwise negative. We go counterclockwise, and the terminal ray, in this case, will intersect the unit circle here at the point xy. Now we talked about that in the last section, but now it comes into play because of using the unit circle. The radius for the circle is 1. We're going to define the 6 trig functions based on this point of intersection of our terminal ray in the unit circle. Let P, the ordered pair xy, be the point where the terminal side of the angle theta is in standard position, positive direction arrow. We define the sine, S-I-N-E, of theta, which we abbreviate S-I-N of theta, to be the y value of this point. So whatever the y value of this point is, that's how we define the sine of this angle. We define the cosine of the angle, C-O-S-I-N-E, COS is the abbreviation of theta, is equal to the x value of that ordered pair. So if you can determine the sine and the cosine, if you start looking ahead at the other 4 trig functions, you can also find the other 4 trig functions. The tangent, now I know we've had like a tangent line to a circle. This is a tangent function of theta. TAN is defined as the y divided by the x. The y divided by the x would be like the sine of the angle divided by the cosine of the angle. The cosecant. Now see, these are all these are the 3 main trig functions that we use probably 75% of the time. But there are 3 others that are used, and as you'll find, they are reciprocals here. The cosecant function of theta, which is abbreviated CSC, CSC of theta, is 1 over y. Notice that it is the reciprocal of sine. So if you know the sine of theta, you know the cosine of theta because they are reciprocals. The secant, which is abbreviated SEC of theta, is 1 over x, which is, remember, the cosine of theta. So the secant and the cosine are reciprocals of one another as well. The cotangent of theta, COT here, for the abbreviation of theta, is x over y, the x value over the y value, which is the reciprocal of the tangent of theta. So you can see the way I've got these paired up, that these are reciprocal functions of one another. Now, we have to be careful. Not so much with sine and cosine. Sine and cosine are defined everywhere. But with tangent, with cosecant, with secant, and with cotangent, they have the variable in the denominator. So we'd have to be careful on getting 0 in the denominator. See, if x is 0, you can see you're going to have a problem here, you're going to have a problem here. Now when would x be 0? Well, on the unit circle, x is 0 on the y-axis, so that would be 90 degrees and 270 degrees, just for those 2 angles between 0 and 360, or pi over 2 radians and 3 pi over 2 radians, again for those angles between 0 and 2 pi radians. And the y is 0 on the x-axis, so that would happen at 0 degrees or 0 radians, 180 degrees, or pi radians. And again, those just being within the first revolution, they're between 0 and 360 degrees, or between 0 and 2 pi. So anyway, keep track of that, because there are times when these 4 trig functions are undefined. Okay? Now, let's look up here. It says, suppose that the real number, and I'm using the variable t here, corresponds to a point P that's on the unit circle. Okay, now what they mean by this is that we've got some real number, they call it t here on the unit circle. What they mean by that is that this distance here, okay, would be referred to as t. That this distance here is the distance that corresponds to this point on the unit circle. They ask for the 6 trig functions. This distance here is this angle right here. We are defining this as the angle, t. And we have some point, in this case the point is the square root of 5 over 5, 2 square roots of 5 over 5. And we are asked to evaluate the 6 trig functions. Well, since it's on the unit circle here, we know that the sine of this angle, t, is going to be the y value, 2 square roots of 5 over 5. The cosine of this value, t, is going to be the x value, the square root of 5 over 5. The other 4 trig functions can be defined in terms of x and y. We know, for example, that the tangent of t is the y value over the x value. So it's this over this. So I would have 2 square roots of 5 over 5 here. I'll write it like this, kind of awkward. All over the square root of 5 over 5. Well, we multiply top and bottom by 5. We get 2 square roots of 5 over the square root of 5, which is just 2. Alright, so we have that the tangent of this angle, t, is 2. Now remember, I just said it's an angle, but it's also defined as a real number. That's why you don't see units on radians, because we like to use the idea of radians to correspond to the number line. So now I need the other 3, which are all reciprocals. So the cosecant of t would be 5 over 2 square roots of 5. Don't leave your answer like this, and don't grab a calculator right away to approximate it. Simplify this. Multiply top and bottom by the square root of 5, and I have 5 square roots of 5 all over. Now the square root of 5 times the square root of 5 is 5, so 5 times 2 is 10. And I have the square root of 5 all over 2. The secant of t is the reciprocal here, which would be 5 over the square root of 5. And again, don't grab a calculator the instant you see a radical and approximate it. You can simplify this radical. This would give me 5 square roots of 5 all over square root of 5 times square root of 5 is 5. And I get the square root of 5. The tangent of t turned out to be 2, so the cotangent of t turns out to be 1/2, the reciprocal of 2. That was really very easy once you have the sine and the cosine. And it comes from this ordered pair because it's on the unit circle. And this is what I mentioned before. As long as we're dealing with theta, our angle in radians, it matches up, the angle matches up with this t value that they're talking about in this example as far as a real number on the number line. Okay? Now, here's where it gets fun. Using special right triangles, we can determine and memorize the sines and cosines of angles between 0 and 2 pi radians that are either multiples of pi over 6 and pi over 4, 30 degrees and 45 degrees, because we can set up 30, 60, 90 and 45, 45, 90 right triangles. Remember, if you have a 30, 60, 90, and this isn't going to be drawn very well, that looks more like a 4. Let's make this one the 45, 45, 90. If we know one of the sides, let's say that this side here is x, then we know that this side here is x because it's isosceles, and the hypotenuse is x squared root of 2. With a 30, 60, 90, let's say this is 30, this is 60, this is 90 here. If we know one of the sides, let's call this side here x, we know that the hypotenuse is twice as long as the shorter leg, and that the longer leg is square root of 3 times the length of the shorter leg. We have that those ratios there, and we can use that to find sine and cosine of multiples of 30 and multiples of 45, or pi over 6 and pi over 4. Now think about this. If you know sine and cosine, you can find the other 4 trig functions. You can find tangent, cosecant, secant, and cotangent because of the relationships that we've defined here. So let's go ahead and find the sine of pi over 6. Now I already drew out a picture here to help us out. That's supposed to be the unit circle. Of course you can't tell that because I didn't put the marks there. That the radius there is 1, center is 0, 0. I'm going to find the sine of pi over 6. Well, it's key to find this point, because remember how the sine is the y value and the cosine is the x value? Let's find that point where our terminal side intersects the unit circle. Well, I do know that if I have a pi over 6 angle right here, or 30-degree angle, and if I drop a perpendicular down to the x-axis there, I've created a little 30, 60, 90 right triangle, and I know one of the sides. I know that the hypotenuse is 1 because it's a unit circle, the radius is 1. So if I know the hypotenuse, I can go to the shorter leg by taking half of the hypotenuse, so this would be a half. And I can find that length of the longer leg by taking the length of the shorter leg and multiplying it by the square root of 3. And so I end up with 1/2 times the square root of 3, or as I like to write it, the square root of 3 over 2. So my ordered pair is the square root of 3 over 2, 1/2. Well, that tells me that the sine of pi over 6 is the y, it's 1/2. And the cosine of pi over 6 is the square root of 3 over 2. Now, all the multiples of 30 and 45, or pi over 6 radians and pi over 4 radians, there's a bunch of them. You've got 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then back to here, back to the x-axis there with 360 degrees. You say, well, that's a lot of sines and cosines to memorize. There's a pattern. There is. And I believe in the lesson, there's a video there to help show you with that, to help you, pick up on the pattern. But you will want to memorize all the sines and cosines of multiples of 30 degrees and 45 degrees between 0 and 360, or pi over 6 radians and pi over 4 radians between 0 and 2 pi. Now, when I took trig a long time ago, my class had 17 students. When our teacher told us that we would have to memorize all those values, by the next week, our 17-student class dropped down to 10 students. There's 7 students that bailed on this class because they didn't want to take the time to memorize, and it was really to their disadvantage. It's very handy. It's one of the things that I have found most useful is to know and memorize, and have memorized all these multiples of 30 and 45 degrees, or pi over 6 radians and pi over 4 radians. This is just one example. And of course, you're going to have a chance to do more. And you'll start, hopefully, in this section, start working on putting these multiples of these special angles, sines and cosines, putting them to memory as soon as possible.